part-time because probably you're thinking about going to lunch, listening to something like patterns and service meshes. But my name is Alex. I work in Red Hat. And, well, I'm contributing to several magazines and websites. And, well, in this talk, you're going to see some kind of advanced use cases for service meshes. If there is any question, just raise your hand at any time. Don't wait until the end. Well, at the end we will have some 3 or 4 minutes for questions, but if you have it just in this slide, you can just raise your hand. There's no problem. So let's start. Some years ago, now it seems like ages, we developed something like that, right? We have our monolith, which was like something like this, which was our application, but of course our application was containing some kind of modules. There's several modules, and these modules inside, they have some kind of components inside. So basically we have a really big application, and then this big application contains some modules, and inside these modules have some components. But then, maybe 2 years ago, we thought that it would be a good idea to start breaking down this application, this monolith application, into something that was called microservices. So we just take each of these modules, each of these components, and we start spreading out and distribute all of them across a network. This network, in fact, it's a graph, it's a mesh, right? It's not just like a tree, it's like several components communicating with several components at the same time. So there is, graph structure, which makes things in terms of architecture really interesting. Of course, each microservices contain their own data. Some contains a database, others not. And even one thing that you need to be aware of microservices is that you can have multiple entry points. There is not just one entry point that happens with monolith, but you can just reach any of the services from outside. And probably for this reason, it's a really good idea to have an API gateway in front. The thing is that you think clearly what it's about this microservices thing, it's about a distributed computing. It's just service A that communicates using the network to service B and communicates to the network to service C. And as a developers, we tend to think about, okay, it doesn't matter, right? In the past I just did a memory call. I just called method A calls method B. It was a memory call. Now it's just, component A calls component B. And yes, I know there is the network there, right? But at the end, it's more or less the same, right? Because I call one method that does something, and then I get the result. The problem is that we assume that as developers, the network is reliable. We never think about that the network can be done, right? We just do the call and all the time works. The latency is 0, so it doesn't matter. I set it and then I get back the result, and it's pretty fast, right? Because I run it on my computer, which is localhost, where it's pretty fast. But then when you go to the production cluster, things are quite different. The bandwidth is infinite. We don't care of what we send across the network. I have all this big JSON document, okay, I send it. Doesn't matter. That the network is supported. The network is secure. We think that nobody can hack our network and just start sniffing the traffic. The topology does not change. There is one administrator, transport cost is 0, and the network is homogeneous. And this is what we think about it. The big problem is that, okay, this is our mesh of services, and what's happened when there is a downtime in the middle of the mesh? Maybe because you are releasing a new version, or maybe because there is an error, maybe because this specific service is down. With monolith, it was like all or nothing thing. And now it's like this error, but it's not just an error focused on this service. The problem is that there is a cascade of errors. So any transitive service that depends on this failing service are going to fail as well. So as you can see, microservices is quite complicated in this sense, because it's not just sending traffic and getting back traffic, but there is you need to configure the network properly, and it's not easy at all to do it in a good way. And for this reason, microservices start creating something that I like to call microservices cross-cutting concerns, which is more or less the same like we had in monolith. Cross-cutting concerns in monolith was transactions, logging, or monitoring. And now in microservices we have other cross-cutting concerns, which are these ones. We've got all service, or service can be implemented with any logic, Vertex, Spring Boot, Quarkus, or whatever. And then we have an API, because we need to be able to expose our service to others. We have a discovery, we need to know how we can discover our services. We need to know how to invocate all the services. Maybe it's HTTP, maybe gRPC, depending on the protocol. We need elasticity, we need to be able to scale up and scale down, depending on the traffic. Resilience, this is a really important thing. It's what's happened when there's one service that is failing. What happened with the callers? The callers should do something. This is about resilience. Then there is a pipeline. We need to find a concrete way of deploying all these services automatically. There is authentication, how we authenticate between services. Usually with monolith, we just authenticate, and that's all. Now we have several services, that maybe some of them requires also authentication. There is a logging. Again, with monolith it's really easy. It's just a file, right? But now it's several files. So we need to find a way to merge all these files to have a sequence of the events. Monitoring, we need to monitor each of the services, and tracing. We need to know what's happening inside our mesh. We need to know, okay, someone sent a request, what's happening with this request inside the mesh? So you can think that this is a disaster, right? Because when we move to microservices, we have all these cross-cutting concerns that we didn't have it before, but now they are there. So you can see it as a problem, or a difficult, or you can see it as an opportunity. An opportunity to what? To start using Kubernetes, or for example, OpenShift. OpenShift is an open source version of Kubernetes that you can install and compromise on your production machines. That basically, it covers all these cross-cutting concerns. So if you're using Kubernetes, you are using discovery. We've got it there because at the end you have a service name. The invocation is also covered. Elasticity with the concept of replicas. With Kubernetes, you can say, I want 3 replicas of this service, and then you just scale up to 3 instances. And that automatically just checks, okay, we've got all these machines on our cluster. I'm going to put one instance in this machine, another instance in another machine. So this is something that is done automatically for you. But also, if you're using OpenShift, you are also covering the problem with pipeline logging and monitoring. So we are covering almost everything, but there is still some important gaps, like for example, resilience or authentication. So what happened to cover these gaps in the past was doing something like that. We've got all, in this case, is in a Java example, but it's exactly the same for any other technology. We've got our container, usually our Docker container. And then we have the JVM, and then we have our service A, and all the cross-cutting concerns implemented inside our code. You can think, for example, in Java there is the Istio library for circuit breaker, but probably for Go there is other library for circuit breaker, for JavaScript there is another one, and so on and so forth. The same for load balancer, for discovery, for metrics, or for tracing. So all this code is always inside our service. And well, then we have service B, and then we have service C, having all these concerns implemented as well, which usually ends up by having a copy-paste from service to service. Because at the end, nobody does copy-paste now, right? So, yeah. And even it's another problem is that if you have service A and service B and service A is in Java and service B is in JavaScript, then you need to learn circuit breaker for Java and circuit breaker for JavaScript. And you need to maintain all these libraries on all this knowledge. But what if I told you that you can implement all these cross-cutting concerns into an infrastructure layer? So instead of having all these concerns, all this code inside our service, and notice that all these cross-cutting concerns needs to be implemented because of an infrastructure problem. All these problems are because we are using the network. If we were not using the network, we didn't need resilience or authentication between services or elasticity, right? Because it just one service. Now with microservices, because of we are using network, we have all these problems. But how about implementing all these code inside in a specific place? Basically, inside a Docker container. So if we will have a Docker container containing all the circuit breaker, all the authentication thing, all the logging, all the tracing, everything there, then we could reuse this container for all our services. So it doesn't matter which is the language, it doesn't matter what's happening, if you are using Go, or you're using Java, or even you don't need to maintain the libraries. Everything is inside the container, and this container is reused across all your services. And this is exactly what Istio does. Istio is a service mesh, and a service mesh is a dedicated infrastructure layer for making service-to-service communication secure, safe, and fast. But when you start using Istio, you need to change how you develop, how you deploy, and how you release your applications. It's not like before that you put everything inside your code. Now it's like I've got my service, which just contains my service, and then there is another part which contains all these cross-cutting concerns that needs to be deployed and released at once. So if we start moving to Istio, we'll see that, well, discovery is something complementary, but we've got resilient authentication and monitoring out of the box. And then this is how now works everything with Istio. We've got our pod. Remember that a pod in Kubernetes is you can think about like the machine, right? It's where everything runs. And every pod can contain more than one container. Usually people think that one pod just contains one container. So it will be pod equal container, but it's not in that way. A pod can contain several containers inside, sharing the same volume, sharing the same IP, sharing the port mapping, and even sharing the lifecycle. In case of Istio, which works like this, is that you have your container and then you have a sidecar container, which is the Istio container. It's not about at this talk that you will say, well, a pod with two containers, that's really strange. But if you're going to start using, for example, Knative, which is this tool for deploying serverless applications, then you will have 3 containers inside a single pod. So I mean that it's not strange nowadays to have more than one container inside a pod. If you are thinking about what's inside this sidecar container, basically there is an Envoy proxy inside. Envoy proxy is like HA proxy or Genix, it's like a proxy. But the good thing of Envoy is that it has been written from scratch to be Kubernetes friendly. So it's written in Go, it works pretty fast, and for example, you can configure Envoy on the fly. So you don't need to change a file and then reboot the service or reboot the proxy or something like that. You just send a REST. It's not in fact, it's not a REST, it's an XDS protocol, but you can think about like REST endpoint where you send the configuration and then it just configures automatically on the fly.
It's like traffic.
What that?
When there is another proxy, it moves very similar to traffic.
Yeah, there is. Yeah, you can think about like a competitor of Istio. Yeah, there is traffic. And there's another one. It's called. There are several. I mean, I think that there are 3 or 4 proxies that are used for doing service meshes. But yeah, I mean this Envoy it's it's done by the Lyft company. They have a huge amount of traffic they are using in production, so you know that you are using a proxy that has been, let's say, just tested on the war, right? But also that Envoy has been chosen by Istio guys to be used to be seen the proxy, or the proxy for Istio. And notice that every service contains a proxy. So now all the communication does not go through service to service directly, but through service to proxy, proxy to other proxy, proxy to service, service to proxy, proxy to other proxy. So all the communication happens across this proxy. And all the services has their own proxy. And in terms of this, you're able to do things like, for example, traffic management. So you can start saying, modifying how the traffic is sent. So you can receive a traffic and say, okay, if the traffic contains, I don't know, this path, send it to this service, but if it contains this other path, send it to another service. Or you can do things like, if the traffic comes from this range of IPs, go to this service, not to this other service. Or even you can do, for example, mirroring traffic. You can just take the traffic and say, okay, now I'm going to take this request and send it to 2 services at once. And this is really useful for doing testing in production, because you can release service B with version 1 and service B with version 2. You send the same request to both services. You only take care of the response from P1, but you are already pinging the service B2. So you can start monitoring this service B2 and check if it works or not. So before releasing, you can check if this service is going to work with the current traffic. And also, for example, you can do dark canaries, which is a technique which allows you to send traffic depending on, for example, the geolocalization. You can say, if this traffic comes from Spain, then send it to this service, the rest goes to another service. Or if the traffic comes from a mobile, send it to this service. It comes from Chrome, send it to this other service, and so on. So you can even modify the traffic in this way. Also, it implements circuit breaker pattern. Probably if you are into the microservices ecosystem, you already know circuit breaker, which is the way that you can detect failures and then react to these failures. It implements it automatically for you. You will see it in the demo. It also implements retries. So when there is an error, Istio automatically tries to do a retry. And this retry is not something that you can think about that it's useful, because at the end, if something is failing, it will continue failing. But Istio implements one thing that I think that nobody implements yet, which is called pool ejection. Basically, Kubernetes inside has a pool of pods. So when you have a pod containing one service, or you would like to have 3 instances of this pod, right? Because you want to be your service replicated across all your cluster. So it has a pool of pods of this service. So when you get a request, you just go to this pool of pods and say, okay, this pod is the one who's going to process this request. Send it to this pod. Then you get another request and say, okay, now it's the next one, and so on and so forth. So usually it's a load balance or a round robin approach. Pool ejection does the next thing. It's like, okay, I send the request, and I send it to this pod, and this pod is failed. Now, since it's failing, I'm going to take out from this pool of pods. And then you will have only 2 pods there that could process your request. And this, used in conjunction with retries, is really powerful, because notice that you might have one of the instances of your service behaving incorrectly, maybe because it's receiving a lot of traffic, maybe because it's failing because there is some failure on this physical machine, and then you send them the request. Istio detects the failure. It says, okay, this service is behaving incorrectly. I'm going to take out from the pool and I'm going to do a retry. And then this retry will go to another instance of this service. And then probably this service is working correctly and will send the response to your client. So as you can see, you can have several services there, that with huge workload, and Istio will take care of saying, okay, there is a big workload in this service. Let's stop sending requests to this service. Let's say put it in quarantine until you get more relaxed, and let's send traffic to other pods which are more relaxed. So as you can see, retrace plus pool ejection is really, really powerful in the service mesh system. Of course, the other thing that you can do is chaos engineering, chaos testing. There are a lot of experiences that I can share with you about companies that told me, yeah, we are using chaos engineering, chaos testing, and it's just a disaster, right? And the reason is that chaos engineering, chaos testing is really hard. You need to learn how to do it. There is like 4 or 5 steps that you need to follow. And then when you are really with confidence that you're going to start doing a chaos engineering, then do it. But I know some companies that they said, okay, we're going to do it because Netflix is doing it, right? Because we read it in a blog post of Netflix, so it's really interesting. We're going to do it, and even there is a really easy tools to do it. Istio, for example, just let you do this couch testing really easy, and people just start doing it. But please take care of what you're going to do, because I know some companies that decided to create some kind of aggressive couch testing, and well, basically the final result was that all the cluster was down all the time. So just try to start experimenting with little cases, with things that you control, and then just move forward to more advanced use cases. The other thing that implements Istio, or service meshes in general, and this is why most of the clients in Red Hat is using or wanting to adopt Istio is security. Basically, with Istio you can do things like do black and white lists between services. You can say service A can communicate with service B, but not with service C. And this is really powerful, because if there is an attacker that, for example, reaches service A and tries to communicate service C because there is the payment gateway or whatever, he won't be able to do it, because you are putting some rules, some blacklist and whitelist on this. Also, it implements MPLS feature. So you just configure your Istio, say, okay, all the communication within the mesh should happen with MPLS, and that's all. For you, as a developer, the service will work with HTTP. But it was going to do an HTTP connection to your proxy. The proxy will convert your HTTP communication to HTTPS. It's going to do the communication to all the services with HTTPS. The other proxy will transform this HTTPS into HTTP, and then it's going to reach the original service. So now you don't have to take care of all these certificates, all these CAs and so on that usually you have to do as a developer in your services. Everything is managed by Istio. And also it implements an airbag system with GWT, so you can just configure Istio to say, look, this is my OpenID, for example, server, and that's all. I send you a GWT token, then Istio will take this token, will validate the token against your authentication authority. If it's valid, then it will pass this communication to the original service. But if not, it will refuse the communication. So you don't need to doing security things inside your service. You don't need to implement anything. Everything is managed automatically by Istio. And also one of the things that Istio does really well is issuing certificates. So you don't need to take care of the certificates or the revoking certificates, or for example, short life certificates. You configure Istio to say, every minute, please revoke all the certificates and create new certificates. This is the CA that you need to use, and then Istio automatically will just revoke the certificate of all your cluster and just create a new certificate. Everything is automatic. You don't need to do anything. And the last thing that it implements really well, Istio, is observability. If you are into microservices, you need observability. This is tracing, monitoring, and logging. And Istio, by just using Istio, by default provides you an integration with Prometheus, and Grafana, and Jigger. Since all the traffic goes through the proxy, it's just a matter of taking this traffic and sending it to Prometheus. So you can monitor automatically all your infrastructure without having to do anything in your code. And usually, when people talk about Istio or service meshes, just shows you a very simple examples, like we're going to do a blue-green deployment, a canary release, and that's all, Python and always work. But now I'm going to show you some more advanced use cases. Maybe I'm more near the real world and not just a canary release. So let's see this in action. I got here my cluster.
Okay, this is my cluster, which if you see here, you see that this is a service or application, very simple, which I have customer, preference v1, recommendation v1, recommendation v2. The important things here is that you can see that there are two containers running. The first one is the recommendation service itself, and the second one is the Istio proxy, which in fact is this envoy proxy running. Okay, now if you check, now I've got nothing configured, just my services, and I can do a code. And it, maybe there is no network. It's fine, but I tried just before. Yeah, the problem is that the DNS server.
That could be your client, your result of conference.
Yeah, but it worked just. But I don't know. But there is a network, right? Compared to the music receive at the end. Maybe the DNS is down. I'm not sure. Let's have to restart that cluster. Sometimes I've got some failures that just represent with restart. What I wanted to show as a first demo is this retry plus full ejection thing. So what I want to do is just create two instances of recommendation v2, and then you will see, I mean, that first all the instances are rich. Then I would set one of these instances to return an error all the time, and then you'll see that this instance never reach the client. Let's see, because this is going to take like strange anyway. I'm just using OpenShift, but it's again it's Kubernetes. In fact, I'm using here Kubernetes the .11 one, I guess. Yeah. So I mean, but it's just a Kubernetes plus all the things that I showed you, the like pipeline. So I put at the end, OpenShift comes with the Jenkins integrated, so you can just build your project inside the cluster that you're going to run your application. But it's a Kubernetes. You'll see that almost all the time they use kubectl. Okay, now let's see. It works. Or one is performing better or worse, or one is failing where the other is not failing. To use this, I suggest you using differential, which is a tool written in Go, but it's it's written from scratch for the Kubernetes friendly. So it's, you know, you can put it on your Kubernetes cluster without any problem. Basically it works like this. Finally, as I said, Istio comes with Prometheus and Grafana, and this you can see all the information that you get for free just for using Istio. Which basically you see that it's for each service. You see here is the services, and then the service mesh, and here is the global rate. So you can configure things like I have service AB1 and service AB2. I put them together, and I can compare directly the global success rate. And if I see that the global success rate is exactly the same or similar, I know that this new version is behaving correctly. But if I see that the global success rate is decreased in the new version, I know that this new version contains some kind of regression. Jigger, this is, as I said, for tracing, so you can see with Istio what's happening inside your mesh for free. And then you also have Kiali, which is a service for Istio, but you know, it prints all the mesh, and you can see the state. You can see here in this case that B1 is behaving incorrectly with B2 of these services because it's rank, but it's working correctly with B1 and B3. So you can see that there is some changes if you're going to use Istio. Basically, the first big change that you will see is that you are going to read off a lot of functionality from your services. I think that it's really nice to have Istio running on production because you're going to save a lot of time, basically developers' time. And that's all. If you have any question, I will be here now around, but also you can tweet me your question. My YouTube channel, I just put there videos about Istio or Quark or microservices. My email, you can send me an email, there is no problem. And finally, this is my blog. Thank you.